how would you convert 3.0 moles of helium into atoms of helium? All right. Over the summer, we did something called dimensional analysis. All right. We're going to use that here. All right. With dimensional analysis, first you need to identify the given, which is usually the number in the problem, and in this case, it's 3.00 moles of helium. All right. Next up, you have to do the dimensional analysis setup, all right, which is whatever you're given over 1. Oh no. Times, I'm glad that's in the video. Times something over something else. We don't know what this is yet, okay? Okay, so now we need to look at the problem and figure out, all right, what are we doing? So it says, how would you convert 3 moles of helium into atoms of helium? So how do we go from moles to atoms? Well, we know the number, right? The 6.02 number. So the conversion factor is 1 mole equals 6.02 times 10 to the 23rd, whatever it is. In this case, it's atoms. All right. So 1 mole equals that many atoms. So what are we going to put down here? Okay, why are we going to put mole on the bottom?
So the moles cancel out.
Yeah, so the moles cancel out, right? Whatever's on the top needs to cancel out whatever's going to be on the bottom here. So it's mole. And then on the top, what are we looking for? We're looking for atoms. All right, and we're talking about helium. Okay, now we plug in the numbers. So it's 1 mole equals 6.02 times 10 to the 23rd atoms of helium. Okay, so let's try to put this in our calculator. If you have the TI, was it 32? 32, you should type in 3.00 times 6.02, find that E button, and then 23, and then enter. If you have the multi-view, you're going to want to do 3.00 times 6.02, find the button that has like an N times 10 with a caret, and then you type in a tiny 23. And then you hit enter, and hopefully we'll get the same answer. We got 1.806 times 10 to the 24th atoms of helium. How many sig figs does this have? 4. How many sig figs did we get from the problem? 3, right? This has 3 sig figs. So we need to round this to what? Yeah, 1.81 times 10 to the 24th atoms of helium. And then that would be our final answer.